As their booster rockets separate, Space Shuttle astronauts typically feel accelerations up to 3 Gs, where a G is equal to 9.80 meters per second squared. In their training, astronauts ride in a device where they experience such an acceleration as a centripetal acceleration. Specifically, the astronauts fasten securely at the end of a mechanical arm that then turns at a constant speed in a horizontal circle. Determine the rotation rate in revolutions per second required to give an astronaut centripetal acceleration of 3.00 Gs while in circular motion with a radius of 9.5 meters.
Okay, so our givens from the problem are that the astronauts accelerate to 3G, and 1G is approximately 9.80 meters per second squared, with the radius of their circular motion being 9.45 meters. Okay, and the problem also states that we're trying to find the rotation rate in revolutions per second. Okay, so to find the rotation rate in revolutions per second, we are going to use the problem AC equals v squared over r. So you can rearrange that to get v equals the square root of the centripetal acceleration times the radius. And so that equals 3 times 9.80 meters per second squared times 9.45 meters. And as you can see, both of these are given to us originally in the problem. So the astronauts accelerated to 3G, which is why for the centripetal acceleration you multiply gravity by 3 since their acceleration is 3G. And the radius was also given, as seen above, to be 9.45 meters. And when you multiply and take the radical of that, you get 16.7 meters per second. Okay, now we have the answer of 16.7 meters per second. However, for that answer, each revolution carries the astronauts over a distance of 2 pi r. And since the answer was asked in revolutions per second, we need to convert that. So what we do, since it's 2 pi r, we plug in the radius which was given into the equation 2 pi r, and you get 2 pi times the radius equals approximately 59.4 meters. Okay, now with that answer of 59.4 meters, you can take that and do dimensional analysis to find the rotation rate. So you have 16.7, as shown above in the answer that we got in the first part of the problem, meters over 1 second multiplied by 1 revolution over 59.4 meters. And then you can do dimensional analysis and cross off the meters, and then you would get 0.281 revolutions per second as your final answer.